Hello, this is Joshua Dean. I'm doing the week 4 presentation for BMIS520. I'm doing it on the modern IT infrastructure design for large global enterprises. Here's the agenda we're going to go through. We're going to go over parallel versus distributed computing. We're going to go over a couple items from AWS, an item or two from Microsoft Azure that they're using. Go over a couple advanced business technologies that are being used in the modern IT world, and then the conclusion. First thing I'm going to go over is parallel computing. Main thing with parallel computing, see the definition here, is just one singular system that runs multiple processors. NASA and their supercomputers do it a lot, and I've seen also where other companies do it for scientific algorithms. Running big algorithms like that, you're going to need a lot of processors, but also keep it quick because it's on one computer, one system. And that directly contrasts to distributed computing. That's going to be when you have the multiple systems all connected to the same network. It's a little less on the speed and more about the scalability, fault tolerance. You got one that goes down, we can fault tolerant over to that one. Biggest one I've seen that uses this, the multiple systems, is going to be Netflix. You hear all the time Netflix uses distributed computing. Couldn't find a good diagram for them, but ideally they're be running this computing because it's scalable, and with the different zones and areas they've got to be in, it just works for them. And a lot of those cloud services as well use distributed computing. So this is just another outline. The difference is you got parallel, same machine, multiple processors. Their biggest focus, like I said, is on speed and gives you that tight synchronization. Distributed, you got multiple machines all networked to the same network, and they focus on the scalability, the fault tolerance, the reliability, loose coupling via message passing via the network. So that's the biggest differences between parallel and distributed computing. Now we're going to go over one or two services offered from AWS. So AWS offers the Elastic Compute Cloud, EC2 service. What this does is essentially a virtual server. You can spin up and spin down virtual servers, giving you the cost as used, as needed. But what it gives is it gives customers an easy way to scale up, scale down virtual servers. You can run databases on here. You can run web applications on here, all sorts of things. And then, like it says here, you can run load balancers as well on those EC2 instances. So Microsoft, AWS uses microservices architecture. I've seen it in AWS being used, but Microsoft really pushes the microservices architecture. Even though AWS, you can use it, Microsoft tends to use it for their Office 365. Essentially what the microservice is just breaking a web application into multiple services in order to better continuously improve, continuously deploy that web application in sections. So easiest instance I've seen where it's a good example is going to be something like your Amazon, right? You got your cart that you store all your items in. You have your ads, you have your account. All of those are separate services. So if the cart service goes down for whatever reason, it doesn't affect the ads that are being ran, doesn't affect the items being shown, it doesn't affect the account management. So it's easy to deploy and develop. A lot of times you have your different development teams for each service. So this is what I've seen a lot in what I've worked with before is microservices. That's about all I've seen. But that is an easier way to continuously improve, continuously deploy, and then have your multiple development teams. Sorry if it's a little blurry, but back to that microservices architecture that goes hand in hand with Docker. Docker is kind of, just to give you kind of the quick rundown, Those microservices are hosted onto Docker containers, which keep it segregated from the host. So just keep it simple. Microservices are hosted in these containers, and then they run separately. Biggest thing with Docker is there's a lot in Docker to learn, but it just give you the quick rundown. It is just where they facilitate the microservices. So containerization using Docker and then using Kubernetes as well. I've seen where that is being used a lot. Orchestrated the modern IT world. Cloud elasticity with AWS, Azure, and Google Cloud. Like I said, the microservices I've seen being used in architecture to keep those deployments separate, keep those different applications separate that kind of come into one application. Automation and monitoring tools for reliability. You see a lot of automation nowadays. You got AWS Lambda. You got your monitoring tools like CloudWatch, CloudTrail, those sorts of things. A lot of monitor tools and automation tools being used nowadays in the modern IT world. Biggest thing here, why modern IT infrastructure matters. Rapid scalability, meet user demands. Users change their ideas every day, it seems like, but at least you have that rapid scalability. You have those microservices, you have those monitoring tools to be able to change on an instance when they do change. If you have a new EC2 you want to spin up, those EC2s are rapidly scaled up, rapidly scaled down. You got a database you want to throw up, you can use that. And it's easy because in AWS, I know for a fact, is run on as needed basis. So you get your cost efficiency as it's being used. So if something's not being used for a long time, it's shut down, you're not guarding that cost day in, day out for it being there, but at least it's off and you can see that you're not gaining any cost there. So, and then down here it says the modular microservices, you have your faster innovation cycles, your continuous improvement, continuous deployment that keep foot stomping. To sum it all up, parallel versus distributed computing serve different performance and ability needs. Parallel is that tight synchronization, that single system, multiple processors. Distributed, you got multiple systems, could be multiple processors, but bottom line, you got your multiple systems running on a same network. A lot of parallel. I said your examples were NASA. Some of those science companies running these parallel systems that run those huge algorithms. You got NASA that runs it a lot to find information about outer space, different things like that. Distributed, a lot of these cloud services use those to connect the singular network. You get multiple systems, multiple environments, and then Netflix uses as well for the performance and the scalability. Cloud platforms being used a lot. Microservices are very agile, very quick, deliver the business needs quickly. Containerization kind of goes hand in hand with microservices, and then automation is huge now with making things faster. So you can automate certain things using the Lambda functions in AWS, for instance. That is it. If anyone has any questions, please feel free to reach out to me. Thank you for listening.